Hi guys, this is Mrs. Gassler, and in this video we're going to be talking about valence electrons and electron dot structures. You're going to need some Cornell paper, a periodic table, and those little periodic tables we're going to add a little bit more onto that. So let's get started. The topic here is objective 5.7. We're going to be talking about valence electrons and electron dot structures. Don't forget your name, date, and class period. Mine are pre-filled out, so if you need to stop to write stuff down, that's okay. Just pause the video and keep going when you're ready. Our essential question is, how do I determine the number of valence electrons and draw an electron dot diagram? So to begin this, we need to figure out what a valence electron is. And the valence electrons, sometimes there's more than one, those electrons that are in the highest energy level. Now remember, we drew some Bohr models frequently where we had the protons and the neutrons here, and then we've got the electrons on the ring. The ones that are on the outermost energy level, the outer ring on this Bohr diagram, those would be the valence electrons. And the reason we care about those valence electrons is because they participate in bonding. When atoms come together to make compounds, or molecules, they participate, there we go, in bonding. It's those valence electrons that are involved in holding the molecules together. We'll be learning about that in Unit 6. Okay, so let's say you want to find the number of valence electrons in an electron configuration. So when you're looking at an electron configuration, what are you going to look for? Well, remember, they're the ones on the highest energy level, so what you're going to be looking for is, the first thing you want to do is look for the biggest number of an s orbital. Okay, it's the s orbital. There's some patterns on the periodic table, Remember, this shows you the energy level that they're on, and notice how we kind of dip down here. So if we're looking at one of the atoms here, it's got a 6 and a 4 and a 5 and a 6. We're going to be looking at the s orbitals, kind of a better indicator of which one is the highest energy level. And then sometimes there's a p, so we need to also look for the p. Remember, all the s's are over here and all the p's are over here. So if it's one of these guys over here, you're going to be looking for a P. If it's one of these guys over here, the S is all you need to look for. So we're going to look for the biggest number of s orbital, and then we're going to see if there is a P of the same number and the same level. Okay? If there is, what we're going to do is we're going to add the S and the P. If there's no P, then we wouldn't add that in there. So we'll take a look at some examples here. Okay, so the examples that I have written down, the first one I have is selenium. So what I'm going to do is I'm going to look for the biggest number. Now remember, I'm looking for the biggest big number. Big number is what I'm looking for. So there's a 1, a 2, a 2, a 3, 3, 4, 3, 4. The 3 went down, so the 4, there's a 4. Nope, there's a 5. 5 is bigger than 4. There's a 4, and there's a 4. So here is my biggest number of an s orbital. Okay, it's a 5. I have to look for a p also, and there's a p right here. So this 5. So my valence level, the level on the outside, is the 5th energy level. Now I have 2 s electrons and 4 p electrons. That means altogether I have 6 valence electrons. So selenium has 6 valence electrons. So let's look at another one. Rubidium is right here. Again, I'm going to look for the biggest big number. So biggest, let me write that there, biggest big number. 1, 2, 2, 3, 3, 4, 3, 4, 5. 5 it is. Okay, S1 is all I've got. There aren't any other 5s in here, so my valence level is again 5. And I've only got 1 electron there, so there's 1 S. That means I have 1 valence electron. Let me write it this way, S1 and S2 and P4. 2 plus 4 is 6. S1, 1 valence electron. Okay, so let's take a look at one more. This is uranium. I know you're really glad you didn't have to write that out. If you don't want to write that out, that's okay. 1, 2, 2, 3, 3, 4, 3, 4, 5, 4, 5, 6, 4, 5, 6, 7. There's a 7 right there. So I'm going to circle it, and then it ends in 5. Now, here I have the 5 on the end, and here I've got the 5 on the end, but here I've also got a 5 on the end, but the highest energy level is not the one at the last. It's not the last of the electron configuration, it's just the biggest big number. So my valence level here is level 7, and it says S2, which means I have 2 valence electrons. So that's how I find it from here, okay? So let's look at something else that's pretty cool, and that is a pattern on the periodic table. So we've got all these electrons here, and then here's the energy levels, and when you combine these things, it turns out that the S and the P pretty much determine your valence electrons. So on your periodic table here, what we're going to end up filling out is this, and there's a star right here in that helium one. So all these guys, we saw this before in a previous video, have 1 valence electron in that first energy level. There's 2 valence electrons there. These guys in here, they can vary, but they're pretty much mostly 2. So I'm going to write mostly 2, unless you want to write a whole bunch of 2s out. I'm just going to leave it there. And then here we get back to the 3s, and 4, and 5, and 6, and 7, and over here is 8, but there's a star here because helium only has 2 electrons, and so it only has 2 valence electrons. It's only in the first energy level, and then we start going up in electrons. So this is 5. I'm getting a little lazy here, so we'll just draw some lines there. So those are all 5, 6, and 7. So this is incredibly useful to know, because then it makes it really easy to figure out how many valence electrons there are for an atom. Because you can do this the fast way, okay, and that is just to find it in the periodic table. And if it ends up being in a tall column and you don't have this handy thing right here, you can just count the tall columns. You see how these guys are shorter than these other guys? So this is 1, 2, 3, 4, 5, 6, 7, 8. Isn't that nice? So if you just count them, that is the number of valence electrons. And then if it's in one of those short columns, it's pretty much 2. It's probably 2. We won't actually talk about any exceptions to that 2 rule until we get to Unit 6, when we talk about how those atoms bond. Okay, so let's talk about electron dot diagrams. An electron dot diagram, its purpose is to show valence electrons. And for the purposes of bonding, we need to know paired and unpaired. So we'll have some sets of valence electrons there. And so to help you think about this, I like to think about my mom. She's kind of silly, and it's a good way to think about it. So we're going to imagine there's a store. It's a really weird store. It's a box. And this store has parking spaces on all sides, but only 2. And it's very much only like this, okay? So these are parking spaces. Now my mother, she doesn't like to park her car near other cars because she doesn't want it to get dented. So she'll park very far away. So my mother is working at the store, and she's the parking attendant, and she's going to park the cars. Now when a car comes, so the electrons are cars now. When a car comes, it parks in a parking space. If it's the first one here, it parks wherever it wants. If it's the second car, it's got to park as far as it possibly can from the first car. So we might start here with an electron or a car, and then the next car that arrives would have to park over here, as far away as it could possibly get. Now the next car that comes doesn't want to park near either of these, so it's got to pick whether it wants to park on the bottom or the top of this little store here. Maybe it parks here. Car number 4 is going to have to park over here. We'll number these guys. And car number 5 now is going to have to park next to somebody. They have no choice, so they just have to pick whichever one. It does not matter which one they park at first. You'll develop I really like to start on this side, and that's fine. And then car number 6 will have to park on the opposite side. And then car number 7 has to pick top or bottom here. And then car number 8 has to pick the last one. Now, because of this setup here and how if it's in here it's going to have the 2 valence electrons. The maximum number of valence electrons is going to be 8, so that's why there's only 8 parking spaces. Okay, so when we draw an electron dot diagram, we just have to keep in mind that the electrons can't park next to each other unless they have to, and we're going to make sure that we always have them on 2 sides, and you see how they're oriented up and down on the sides and side to side on the bottom and top. All right, so let's draw some. Boron, we're going to need our periodic table. Where'd my periodic table go? Boron is right here. Boron is in 1, 2, 3, the third column, so it has 3 valence electrons. So I'm going to write the symbol for boron, and then I'm going to park my 3 electrons. 1, 2, 3. Now you could pick any 3 sides really when it comes to boron, depending on where you want to start. For bromine is right here. So this was 3, 4, 5, 6, 7. So bromine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. Notice how on the side my dots are oriented up and down, and I've tried to make them be like the side of a box, like on our little store up here. Calcium is Ca. Calcium is right here. It's in the second, so it has 2 valence electrons. Now I could write it like this, or I could write it like this, and as long as they're on opposite sides, either one of those would be okay for calcium. Carbon is pretty easy. Carbon is right here. That's 1, 2, 3, 4. So it has 4 dots. That means we're going to have 1 on each side. Now you have to make sure that you have sides here. Some people like to, I'll show you on one down here with neon. Some people like to just kind of make a circle around there with the dots, but that's not what we're doing. Neon is over here in this last column, and you might remember from here that that means it has 8 valence electrons. So I need to put 8 dots. That means I'm going to have 2 on each side. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so neon has 2 dots on all sides. Now, what you don't want to do, and I'm going to write it here and do it anyway, is make a nice pretty little circle, because later on you're going to need to know which dots aren't paired up. So get them nice and close together. Make sure it's obvious which side they're on. Phosphorus is a P. It's right here. The other thing you can look at is you see this 13, 14, 15, 16, 17, 18. That last number, 4, 5, 6, 7, 8, with the exception of helium, tells you how many valence electrons there are. So phosphorus has 5. 1, 2, 3, 4, 5. I could put that set of 2 on any side. It's all good. Selenium is Se. Selenium is right here. It's in this column with 6 valence electrons. So I've got 1, 2, 3, 4, 5, 6 valence electrons. And then I've got sodium, Na. Sodium is over here in this first column. Here we go, 1, 2 valence electrons. 1 valence electron for sodium, so it just has 1 dot. Does it matter which side I put it on? Nope. I can totally choose, but that's how we draw electron dot structures. So plenty of practice in your homework. Make sure you work on that. Ask your teacher if you have any questions. Thanks for watching.